Welcome to today's webinar, Spring Cleaning for Your Data. This kicks off our spring data management seminars, so thank you for being here today. This session is being recorded and you'll receive a notification when the recording and the slides are available. So I'm Julie Goldman, Research Data Services Librarian at Countway Library at Harvard Medical School. And in today's session, we are going to review some data organization recommended practices. You'll be able to take these practices and apply them to your files and projects, and I'll identify tools to help you with your data cleanup. Please feel free to ask questions in the chat or save them for the end. First, let's start with a quick overview of research data management. With data management, we really use this term to refer to the active and ongoing management of our data. Managing data is about knowing who created it, why it was created, what it's about, and where it is. So basically, can you or someone else find and also use your data? And data management happens throughout this life cycle of a project, as depicted on the image on the slide. So therefore, we really consider data management a continuous and iterative process with many practices involved. So today's session is called Spring Cleaning Your Data because, it's almost spring here in Boston, Massachusetts, and traditionally spring is known as the time to tidy up and clean the house. But what about your digital stuff? So this is also a great time to clean up your data. The time you spend doing a good data cleanup will more than pay off in increased efficiency in your workflows and your project time. So therefore, today we will focus on some recommended practices for cleaning up your digital records. We will focus on folder organization, file naming, cleaning up spreadsheets, preparing data for analysis, documentation, and data storage. And if you are new to RDM, Research Data Management, it may not be clear how to integrate these practices into your work. So today I really want to show you how RDM can happen ad hoc, one process at a time, compared to these management practices that occur throughout a project in order to optimize that goal of having someone find and reuse your data or your work. Before we dive in, it's important to have a goal for your data cleanup. So like in your house, you usually tackle one project or area at a time. For example, cleaning the refrigerator is one concise goal and has many steps involved. Like you have to take everything out, you throw away expired products, you wipe down your shelves, maybe you add some storage containers, and then organizing everything back into the refrigerator. And then you want to maintain that nice, new, organized refrigerator over time. So I'm going to pause here for everyone to think about their digital content or the projects that you are working on and determine what you want to clean up. So first, you want to figure out what you want to accomplish. Don't worry about the how to do it yet. We will get into those strategies. And I've given you some ideas, some examples here on the slide. So you may want to, name files for a specific project, or maybe you want to back up your dissertation files. I encourage you to write that down, or you can even feel free to share that in the chat. So take a minute to think about what your data goal is. Something that you would like to get out of this session. I will pause for a few more seconds. Great. So I hope you have something in mind And now we will go through some practices to help you get your data cleaned up. Let's start with evaluating your files. So here is a folder with some file contents, and I have some questions for you to evaluate what we are looking at here. If you were asked to, work with the most up-to-date version of that file, could you? The folder is not especially structured, but could you figure anything out from the names of these files? And without other information, could you understand the relationships between the different files in this folder? Any observations that you can take away from the files that we're seeing here? All right, so basically the answer is no to all of these. Someone suggesting maybe the file with final is the most up to date, but as you notice, there's also two file names with file in there. We have a copy of a file with a final in the name. Also, we have many different types of files here. Are we working with a spreadsheet, the CSV file, or the images, or there's a PDF? And everything is named data, and there are multiple versions. It's not very helpful. And even with some other information, maybe you could make some relationships between the different files. So if you have chosen to organize some files, you first need to review and evaluate what you have. Maybe you have a bunch of stuff that's named the same thing that you need to actually open and take a look at and then rename accordingly. But it's a very good idea not to tackle too much. Recall, we are only cleaning and organizing the refrigerator right now, not the entire kitchen. So to perform a thorough review of your digital files, I recommend two approaches. So one is snapshotting, and this is capturing files at a defined phase of the project. For example, between data collection and data processing. So this would include your data collection instruments, your protocols, maybe your process data, or project outputs like a report or presentation. The other is creating master copies of key files. This is typically done at the end of the project, but it could be done at determined project stages as well. This includes records of a project's important files that have been fully processed and have undergone some quality control. We usually consider this part of an audit trail, which is required in clinical trials and other regulated research. But both of these practices involves identifying, preparing, and collating key research files as to identify their provenance, improve future retrieval, and to reduce effort when preparing for maybe giving files to someone else in a handoff, or if you are sharing your data. You also need to determine what you can get rid of. Recall our folder with files in multiple versions and duplicates. We should have a clear picture of what the old files are and the current working files. Then we either archive files that are important to the project, or we delete anything that isn't, anything we don't need. And this is a nice flowchart determining what to do with your files. There are some additional concerns like security and backup that are included in this chart, and we'll mention those later in the session. So after evaluating what you have, the next practice is to organize. Organizing your data is one of the most important aspects of data management. This includes several elements, like including thinking about names, structures, and relationships. It's not just organizing your data files, but also that documentation, any code, maybe even physical samples that are related to your data. All right, so here is a spectrum of practices for organizing your data. And you may be anywhere along here. So I really invite you to determine where you are and where you want to get to. If you are new to RDM, your practices may be neither standardized or documented. Every time a researcher has to manage their data, they have to design new practices and new procedures from scratch. So for organization, this may mean you don't follow a consistent approach for keeping your data organized. So it often takes time to find things. And then moving up the spectrum, ideally, you want to be optimizing your data for that reuse by you and others in the future. So for organization, that means that you organize your data so that others can navigate, understand, and use it without you being physically there. However, this takes, time and practice to get to. So for today, maybe determine if you have that one-time approach or can develop some practices for your current project. Then make data management a regular part of the research process and work your way to that data reuse. So keep this in mind as we work through the additional practices. So let's look at some recommended structure for organizing your data and files. You may have seen, similar examples in the past or in our other classes, but overall, everything gets its own place and should be arranged hierarchically. To come up with this system, you determine if there are groupings in your data, ways you can divide your data into categories or attributes. These attributes may be projects based on date, data collection location, file type, or analysis type. In our example project here, we have a top folder for our project and then some subfolders for our data, code, and documents. Also notice that our data is divided into both raw and processed data. It's really good practice to keep your raw data separate so that you don't modify or lose it. And while there's no ideal, system for organization, it's just a best system for a given research project and the data you are working with. So it's a good idea to take this structure and then adapt it to what you need. All right, let's move on to file naming. So let's say we have opened the file data.csv and the contents we see here are shown in the slide. In its current form, could you say what this data is describing? If you receive this data maybe from a collaborator, what questions would you have? And do you think this data is complete? Give you a second to think about that. Right, so the short answer is no. We have a very unclear file name of data. We have some unnamed variables with some ranges and a count of some type. What do variable 1, 2, 3 stand for? And what are the numbers indicating? So this data is not complete. So to start with, let's break down a good file name, a good informative name. Ideally, your file names should include whatever information you would need to easily locate a specific file. For files associated with a specific research project, it's often a good idea to maintain the standardized file naming convention. And these standardized conventions are a system of naming files that is consistent across a group of related files. So a good file naming convention works for this group of related files, displays about 3 pieces of key information about a file, and is easily visually scannable. You can easily read it. Place the most important sorting information with a context like the study name, experiment number, location, or date at the beginning of your file name. A note here, if you are using a date, use the ISO 8601 state standard. That has the format 4 digits for the year, 2 digits for the month, 2 digits for the day. This ensures that consistency and allows files to be sorted chronologically. If you are maintaining different versions of the same file, you should consider documenting what the difference is between your versions. Whatever convention you end up using, make sure your file names are unique, descriptive, and meaningful. Some tips here: you want to avoid spaces or special characters in your file names, since these might cause some problems for you or other researchers who may want to access your files on other systems. So let's use this naming convention to rename our data CSV file. So using that naming convention, the new name of our file, example study underscore participant 01 underscore version 01.csv, includes the name of our study, a participant ID number, and our version number. So presumably this file would also be accompanied by some documentation that describes the contents of the file and any changes between this and subsequent versions. So since this is a file for one participant, if we were to compile the data in this file with data collected from other participants, we may come up with another file that would match our naming convention, that would be something like example study underscore combined underscore version 01. Again, with that accompanied documentation. Exactly what information you should include in your file names will again really depend on your data, your project, and how you plan to structure your files. So if at the beginning of the class you wrote down the goal of you want to standardize file names for your project, typically I would suggest you start implementing a new file naming convention from here on. However, if you are in the mood for spring cleaning and need to rename current files and you have the time, there are two tools to help you. So here I've included two bulk renaming strategies and tools for both Mac and Windows, but there are many other tools that you can use. The key here is to identify a group of files that need to be renamed, develop your organization system, develop your naming convention, then do your cleanup. Also, you want to get your whole team or department involved in this so everyone comes to a consensus on what makes sense for everyone. This is a really good exercise if you want to get everyone together involved in the data management process. And you can also explore what people's pain spots are in order to fix them with your organization structures. Moving on to preparing and analyzing our data. So there are two sections to this. First, it's preparing our data. So it's often said that 80% of data analysis is spent on the process of cleaning and preparing data. So this involves both ensuring your data exists in a form ready for analysis and ensuring that you have documented how and why you've prepared your data in the way you have. We will talk about working with data in spreadsheets and cleaning up tabular data so that it is analysis ready. Second, there's more to analyzing your data than running statistical tests, summarizing comparisons, and creating visualizations. It also involves ensuring a future you or a future other researcher can understand and replicate your work. So be sure to document, document, document. Here's our spectrum for practices for preparing and analyzing your data. You may be anywhere along here. So again, determine where you are and where you want to get to. If you are new to RDM, you may find yourself redoing analyses or having to review things to determine what you did. Ideally, you want to be optimizing your data for reuse so that the specifics of your workflow and decision-making processes have been documented and therefore understood by others and yourself. Let's go into some practices for preparing our data. First, working with data in spreadsheet files. So working with data in spreadsheets is time consuming because data is often what we call messy or not in proper format, ready for analysis. For data to be analysis ready, it meets what we call these tidy data principles. A tidy data set is about only one type of thing or event that has been observed a certain number of times equal to the number of rows using certain measurements and identifiers equal to the dataset variables. Basically, this means each variable is in its own column, each observation is in its own row, and each value is in its own cell. So data often comes in this wide format, seen in the visual on the left, because that is facilitated data entry or human inspection. But on the slide, it shows how you would transform this wide data table into a tidy data set with one row for the field site, then a column for the measurements made at each of those time points. Additionally, the principles of file naming and organization can be applied within our files, within our data tables. So see how our column headings are not variable 1, 2, and 3. They're more descriptive. So expanding on that, let's revisit the contents of our file, formerly the data as CSV, now example study, etc. So changing the variable names into something more descriptive and meaningful provides a lot more information about what's in our data set. We can now infer that the data contains information about temperature, resting heart rate, and oxygen saturation collected over the course of 5 days. So see how the variable names are more descriptive, they don't have spaces, but they are still short. However, again, to fully understand, replicate, and build upon this work, we still need some additional documentation. All right, next on to data cleaning. One reason data cleaning is such a challenge is that information is naturally unstructured. Meanwhile, our analysis tools like R really prefer precise data structures. So to prepare our data for analysis, it's important to have a clean data table. And data cleaning is defined as the process of detecting, diagnosing, and editing our data. So we've talked about fixing data structure, but you might also need to clean up your data entries for standardized language, spelling errors, white spaces, duplicates, and other issues. As with all our data practices, it's important to know what we did with our data. So any processing or cleaning to our data set, you want to capture that. And a great tool that not only helps us clean our data, but can automatically capture our steps in a way that can be applied to multiple data sets is OpenRefine. OpenRefine is an open source data cleaning and transformation application used for data wrangling, and it really supports this reproducible research. There are some, nice qualities of OpenRefine listed on the slide, but basically it can be used to standardize and clean your data across your file. And it's really more powerful than working in Excel or a spreadsheet program. I highly suggest this for cleaning your data. If you're interested in this tool, I have some recorded trainings available. There's great documentation online, or I'm happy to set up another live training. All right, so it's great when you can use a tool like OpenRefine that captures our process as we go, but not everything we use does that. Therefore, we typically need to be active in our data documentation. Documentation refers to information that is needed to make use of your data. In general, you should maintain documentation at both the project and the file level. So there's some examples on the slide. It's not an exhaustive list, but it illustrates the type of information you should try to document. So project level documentation includes information about the processes used throughout the project, including how you are collecting, organizing, and analyzing your data. And then the file level documentation includes details related to those individual files. For example, even if you think you'll remember the names of your folders, files, and variables, it's a really good idea to document everything. And documentation can be maintained in a variety of forms. It can be as straightforward as developing a regular practice of documenting your process in a Google document, or formal as maintaining a formal lab notebook. And here are some common forms of documentation on the slide. So a README file is a text file located in a project-related folder that describes the contents and the structure of that folder or data set, so that you can locate the information you need. You may also have a data dictionary or a code book that defines and describes the elements of a data set. A protocol describes the procedures or methods that you used in your research project. And then lab notebooks are primarily that record of the research process used to document your hypotheses, your experiments, your analyses, and your interpretations. So going back to our ongoing example, here's our file. But here is, we're looking at a simple data dictionary for our file. So it includes the name of each of our variables, the variable name written out in plain language, and the information about the attributes of each variable, including units. However, this is just about the variables. It does not contain information about the steps used to collect this data, or the software used, or details that would be necessary to understand and build upon this data. Much of that might be recorded in maybe a protocol. All right, our last practice is saving data. Saving data means storing research materials so that they can be accessed and used at a later date. And the factors to consider here are where you will save things, when and for how long you will save things, and what formats you will be saving things in. For example, the time frame on saving data, according to Harvard University retention policies, research data must be archived for a minimum of 7 years after the final project closeout. However, many institutions have different retention policy timelines. Like our other practices, here's our spectrum. Ad hoc practice is considering data storage and saving data when you are working with it and saving everything in one place. Ideally, we want a system in place for regular saving and backing up important research files. Additionally, you want to save data in places that will maximize data reuse by yourself and others. This first piece of data storage is to understand where you can actually save your work. Here, we're looking at the Harvard data security levels to help you determine what type of data you are working with. Most research data is considered low risk, 1 to 3 level data. The exception is this regulated data, which includes data containing protected health information. That gets into level 4 and above. So related to the type of data you are working with, there are approved storage platforms and tools for each data type. And you can explore those at the link on the slides. You also want to have multiple backups of your data and important files. You should identify both the amount of data that will be backed up and the relevance to your research project. And the basic storage strategy for backing up your data is the 3-2-1 rule. This rule means 3 copies of your data, 2 storage formats with 1 offsite. Lastly, as you shift from saving your data, as you work on it, to saving it to preserve it for the long term, something to consider is your file formats. Open or non-proprietary formats are those that can be used and implemented by anyone. So in practice, we want to be using these open non-proprietary files. The chart highlights some common file formats and data types. In practice, you might not be able to save your data in these formats in every situation, but this is a good starting point for thinking about how to prepare your data for preservation. We are at the 30-minute mark of our session today. I want to thank you all for being here. Before I wrap up, I want to take a moment to hear your feedback. Please take a minute to complete this survey while you're on the call with us today. You can use the raise your hand function or let me know in the chat when you have completed this, and then I will wrap up today's session. I'll pause for a minute here while you complete the survey. Thank you. Thank you everyone for your feedback. Let's wrap up today's session. So I hope you have an actionable takeaway from today's quick session. Recall what you wrote down at the start of the session today, what data cleanup you want to accomplish. Do you have more direction to make that happen? I hope so. Remember to start small. So if you want to organize and name your files, first determine what files you are going to focus on and get your team on board. For example, if you work with image files, focus on that subset of files, then build on from there. Here are a bunch of resources to help you with your spring cleaning. Check out the Harvard Biomedical Data Management website for more information on the practices we talked about. We have seminars all spring long, and all these sessions are recorded and available on YouTube. Thank you for joining. The recording and the slides will be posted on our website. Please remember to fill out the evaluation survey. We will see you next week for data sharing recommended practices. I am happy to answer any questions.